So we stop here. Object literals don't require instantiation using the new operator, but shouldn't be used at the start of a statement because the opening may be interpreted as the beginning of a new block. So it doesn't require you to use the new operator to be able to construct object, but it also requires you not to put that or implement it at the beginning because this may be interpreted as a beginning of a new block. Outside of an object, new members may be added to it using the assignment as follows: my module that property equals some value. So outside of this object my module, a new member inside of this like a property may be added using this format. Here's a complete example of a module defined using object literal notation. So here my property colon some value inside it. So key value first, and then we have another object here, my config colon. Inside this we have key value, use caching and true, language, and English. So object literals can contain properties and methods. It can contain a property or a method. Here we have a method, here we have a property. Like we can define a further object for module configuration. Here a very basic method, output a value based on the current configuration. So it's another method, report my config console.log, and then override the current configuration. So it's a method as well that override the current configuration. And then here my module that say something. So let's say we have called the my module that say something method. It will output where is Paul Irish debugging today. Another my module that report my config. So this is how we call it outside the method in the same file using object literals. My module that update my config, and then we put the key value that we need, we want to update, use caching false, and then closing. Outputs, caching is disabled. My module that report my config, it will show that caching is currently disabled on that object. Using object literals provided a way to encapsulate and organize code. So that's the key. As you can see, it encapsulate first an object for you to create that object first in your code, and then later you access the properties in that code. So it provided a way to encapsulate and organize the code. Rebecca Murphy has written about this topic in depth should you wish to read into object literals further. The module pattern, so this is where we get the new ones now. So it stems from object literal. The module pattern was initially defined to provide private and public encapsulation for classes in conventional software engineering. So the private and public that we are constantly using in our code is actually came from module pattern. So it started from the discovery or from the prevalence of the module pattern. At one point, organizing JavaScript application of any reasonable size was a challenge. Developers would rely on separate scripts to split and manage reusable chunks of logic. So JavaScript, as we will later see moving forward, is that they inherently are designed like this, using a separate script, like an object interacting with other object, etc. So that's how they create an application using JavaScript. But those inherent properties that allows you to create complex things, a combination of complex things, kind of like with the terminal back then, where you're allowed now to combine different commands in a one terminal line. Here, you're allowed now to JavaScript invented a different function or script that executes on each other. Now the issue with that is that it is not organized, and it can easily become very complex. So here what happens is that the module has been created, but this module has also disadvantages as well, as we will later see. Developers would rely on separate scripts to split and manage reusable chunks of logic, and it wasn't surprising to find 10 to 20 scripts being imported manually in an HTML file to keep things tidy. So imagine importing 10 to 20, it's gonna be hard to gloss over. Using objects, the module pattern was just one way to encapsulate logic in a file with both public and private methods. So remember when I said that JavaScript is an object-oriented, inherently object-oriented? That's also a way of saying that function interacts or executes on another. Because what does this object do is that they have inherent functionality. So this module is just a one way to encapsulate that, because this follow the class-based organization. So it's just a one way to internalize or organize rather. So there's another way, but basically the point is that we're still dealing with those objects interacting with one another. Over time, several custom module systems came about to make this smoother. Now developers can use JavaScript modules to organize objects, function, classes, or variables, such as they can be easily exported or imported into another files. So over time, not just the organization of these objects which created the module that mattered, but also how efficient you would store that in a module. So another thing is that a class, okay, it's not a class, but it looks like a class when you look at it from the perspective of another language. So you can store in this module an object, function, classes, or variable. This helps prevent conflicts between classes or function names included in different modules. Figure 7.2 illustrates the module pattern. So another thing that it provides, not just the organization, but also about reducing the conflict between the classes and function, because now you can easily tell what object is this for, and this you're better basically organized if it's a public or private, what's being private, what's being public, what's being included in this module, etc. So here a module pattern. Here's the module consumer that consume the public method of this module and then consume the public property, but the private are all remain private. Privacy. So this is the first topic that you would need to discuss when tackling the module, is the privacy. The module pattern encapsulates the privacy state and organization using closures. So this closure, as you will later see, is also the building blocks of React. So components are able to own their state using closure, and React also came from JavaScript. It provides a way of wrapping a mix of public and private methods and variables, protecting pieces from leaking into the global scope and accidentally colliding with another developer's interface. So imagine you have another developer that also use that same name. But that like property or method could have just changed over time. It's really unimportant with the class, what the class overall purpose does. So in that case, you will be leaking a global space that has been used by another developer writing a code in your code base. So that's a benefit of that, not just a privacy, but also protecting that global namespace, and also providing an abstraction to make sure to tell the other developer what's important and what's not important. With this pattern, you expose only the public API, keeping everything else with a closure private. This gives us a clean solution where the shielding logic does the heavy lifting, while we expose only an interface we wish other parts of our application to use. So just like with keeping the state within a component in React private, it's also doing the same way. So this is one of the principles that allow us to manage our application code complexity better. Another way of looking at it is that this is the implementation, the private, and your public API is the interface. The pattern uses an immediately invoke function expression where an object is returned. So the immediately invoke function expression is that, let's say you created this object, you will return the return value, and that value will be used by your public API that then will be used by another developer. But since you return that within an object, that implementation will remain private, because those implementation could change anyway, right? There could be a lot of different ways to do something. So see chapter 11 for more on IIFE. So we will discuss that further in the next videos. Note that there isn't an explicitly true sense of privacy inside JavaScript because it doesn't have access modifiers. Unlike some traditional languages, you can technically declare variables as public or private. So we use function scope to simulate this concept. So other languages has access modifiers that allows them to have true sense of privacy. In JavaScript, we don't actually have that feature, built-in feature, so we use functional scope, such as this function or for this, that allow us to make it private. There's really no private built-in. We're just using or doing it in a certain way that we scope the function in order to make it look like private. Within this the module pattern, variables or methods declared are available only inside the module itself, thanks to closure. So the variables and methods defined inside that object are only available to that object because of that closure. Just like the state is only available with the component, right? So however, variables or methods defined within the returning object are available to everyone. A workaround to implement privacy of variables in return object uses weak map discussed in this chapter in modern module pattern with weak map. So if you return not a value but a variable or method, those will be available to anyone. Let's just continue here a workaround in the next video.